something yesterday, by the way. Let me share this quickly. Is it
Saw
screen?
the picture you posted of the thing. I think that actually, if you understand the extension, well, the type extensions, that's actually a bit clearer from the previous one as well. The birthday.
Yes. I agree. Yeah. This is what I wanted to see. And actually, my issue was this for all thing. I just hadn't put that in. So if I take that out, it says type variable A is undefined. So it's like it doesn't know what A is. But it's wanting to know what it is. So I actually don't know this. I googled it quickly, and it's called the quantified type. So you're like saying, oh, for that type variable A. So this new function says the birthday prime or whatever, takes any old record which has got an age field in it and anything else. It doesn't matter what the anything else is, right? Birthday doesn't care what the anything else is, but it's like it needs to be type checked. So at least, and then so what and I'll show you why. It's because what it returns is a record that has this field and that same stuff over there. Do you know what I mean? So this A must be the same as that A. That's what we're saying in our signature. And it's like, yeah, that's perfect. So it means that the compiler is type checking that what we return doesn't add anything, because technically it could be like, oh, it could return something of like a different type over there. Do you know what I mean? That's
Yeah,
definitely
you
not
could
what
add
the compile
something with
does.
an extra property or so.
Or something, right? So now if I say, well, now it takes something with an A, with stuff on an A, and it returns a different thing over there. Now the compiler is saying, yeah, but you don't do that. You are returning actually the same thing. So it's like quite cool, actually. It's like the compiler's type checking that stuff for us. You know what I mean? So then, yeah, this signature is nicer now because it's very compact. Now you can read this, and without having to have introduced some new kind of like aged thingy that we did before to solve this, right? It's actually quite neat. So that's cool. I think we've probably, unless there was anything else with, and I know we started with the pattern matching, but I think we've probably got pattern matching in general. I think we've got the basics. We're going to pattern match a lot, so as we write some examples and stuff, there will be a lot of pattern matching. There was just one other thing I maybe wanted to add to pattern matching, something called guards, which are a little bit more powerful. So it's like, I think we created some like weird scenarios here where it was 0 and an x plus x or something, and then this was like, I don't know, 5 and y or something. I just want to get rid of that compile, the warning there. So another little thing you can add to pattern matching, which is pretty powerful, called guards. So you can say, you put this little pipe character there, and you can say where like x is greater than 5 or something. So you can add, so even though this is an x and it'll match it, and it's not one value like 0, it's x, but where x has got a condition. You know what I mean? So it goes into the matching side of it. So let's just go x and y. This is like the dumb case. This will catch all, right? That last one is kind of like a catch-all case. So now if I say we're good, this one still looks like the catch-all one, but it's like for only where x's are greater than 5. Do you know what I mean? So that's what the guard does. You can use them in interesting, but there's some like other syntaxes for guards. You can use them in a bunch of different places. But I think that's like everything you need from pattern matching, right? So when a function is being invoked, it's not overloading as we talked about, because it's not matching different types. It's matching values of those same types, and it's destructuring at the same time. Oh yeah, there is one other thing to be able to do, which is to say, like say for example this one, f with 5, right? So x here would be, so effectively x is kind of like equal to 5, and so on the right side we still maybe want to refer to x and not refer to 5. Do you know what I mean? You can use an @ so you can use an ampersand like that, which is now going to, on the right side, actually set x to whatever it was, which is obviously always 5. Does that make sense? So it's kind of like I'm giving a name to so it's going to destructure this 5 still into the x, rather than having it, because like without that, I don't have x on this side. So it's like, oh, it would have to be 5. Do you know what I mean? And I'm going to repeat that value over there. Does that kind of make sense? So I can name it. I can just name the match.
I just have a question on that. Like,
Yes.
when would you actually use that?
In weird scenarios, you would. It's because I could be destructuring. So it may be an interesting use case. This is one I use a lot, and I think actually it's used often. So maybe it's a good example. Is like, say, what do we want to do? We want to go and like something that takes lists is always a good example. So we say, okay, so maybe we want to sum up. Let's implement like the sum function in a very dumb kind of way, right? Yes, yeah, sum function is a good one. So we're going to say sum. We're going to make our own sum. I don't think we use sum, but we do use sum, so that's fine. So we'll call it like sum prime. And sum prime is going to take a list, and this is just going to be, there's no weird type variables here, but it's going to just take a list of ints, and it's going to give us back an int, right? Happy with that. So we're going to count up all the elements in the list and return it, yeah? Happy with that. So as our first parameter to this, it's the list of ints, right? So we could say list of ints. That's cool. And now instead of calling the sum function, we're going to like now implement this. So how do we do this actually? Any ideas as to how we may sum up? Just jump in, Vincent. I don't look at hands up. Just speak. You need to unmute though.
Okay. Yeah, my bad. So with regards to the guard, quite naturally the lint is complaining with me that we haven't covered all the cases.
Yeah.
Okay. Yeah, just that's about all I wanted to say.
Right. So the cool thing about the guard is the compiler will check it. So it will make sure that you are covering all the cases. Yeah, it's actually quite interesting. There could be like, if you go f of x equals, let's go x. Yeah, okay, so let's go f of fx, yes, and we say, hey, where x is greater than 5, the answer to that is 10, right? Here's our new definition for f. Should I get rid of these things? Yes, and so what is our error here? Is this because I haven't done this? Yeah, some of that is 1, that's fine. So is there a warning here? Oh, it needs a type declaration, that's fine. F taking an int, returning an int, that's cool. And now it's going to say, so you can only invoke this function f with x where x is greater than 5, right? So the compiler is saying, yeah, but what if you call it with 4? It's like, you haven't implemented that case. So it's like, okay, so we need an f of x where maybe x less than equal to 5, and that is 5. And now the compiler should be happy with that. Could not determine all of them at a partial. So it doesn't like that. What have I done wrong? Less than or equal to 5. So maybe if I just say x is equal to 5, then it solves it. So okay, so maybe it didn't exhaustively check all cases of x. Kind of assumed it would. No, doesn't happy. So kind of.
What else? Like a case statement where like you can't put a condition on your default. If that makes sense. So it's like the last case or the last part of your like switch case has to be like no matter what, it will land in here. If you supply it, obviously, but this requires the default.
But I'm almost sure that if I say, well, f of x is any other value, isn't it like this is unreachable now? Because like what else could it be? Isn't this technically unreachable? I don't know. It's like maybe something to go and explore. Is there any other case that x could be other than greater than 5 or less than or equal to 5? Not really.
So I think it is unreachable. I think it just might be the way it's syntactically checking it. It might
compiler can't check it. I don't know. This actually surprises me. I'm surprised that that's a problem.
I think Miguel's right there, because that's a very simple thing, right? But you could have an extremely complicated function with an extremely complicated set of guards, and it would be very difficult for the compiler to check it.
I think it does check them, Vincent. I think it would.
Well, it's not checking now.
Yeah, it isn't now. So I'm saying I'm surprised by it. I don't know. It's interesting. Yeah. So maybe there is some deficiency specifically around gods. I don't know. Okay, but interesting. I mean, that's how gods work for sure. Yeah. It is strange that I have to put. I would assume it can check exhaustive stuff. I bet you Haskell does. Anyway. Okay, so we're back at sum, right? So anyone got an idea as to how we may sum up this list of ints actually without using the sum function provided to us? How may we add up a list of ints?
So there's the declarative route where we just have a loop inside and add the value, which wouldn't be language, well, not language specific, but for
create
this
a variable var x equals naught for I in list of ints.
I don't think that would work. Yeah, though.
X plus equals I.
Yeah, pretty much.
Yeah.
No,
I've got you. I think this one is
functionally-
disqualified for a few reasons. Any other ideas?
I think
check
you have
the
to do it
basic way.
recursively. You have to do it recursively. Yeah.
Yes, cool. So, yes, recursively is the right answer generally. So it's like like we've got to do an operation on one of those elements and then somehow use the stack to add them all up. That may feel uncomfortable. It's something that you may not have written a bunch of recursive stuff in the past. Maybe you have actually, and it's just a style. So wherever you see things like summing or whatever, it's kind of like a fold operation. I'm taking a lot of elements and I'm bringing them down to one. I'm probably going to use recursion for that. It's really so wherever I go for a for loop, in my brain goes for a for loop. It's like I can't do that. I have to use recursion instead of the for loop. So wherever you see for loops, wherever you think for loop, think recursion instead. Okay, so we know we're going to do this recursively. Any strategies as to how this may happen? Talk me through a recursive summing of a list of ints. Who's brave? Matt. Matt would know how to do this. Bhavesh, go for it, Bhavesh.
Well, I was just going to say I have a strategy on how to do it, but the details of the strategy, I have no clue.
Yeah, no, so
but
talk strategy.
So I would start with maybe the terminal case and then get into the recursive part afterward. But what the terminal case should be, I have no idea.
No, that's absolutely brilliant. Yeah, exactly. That's 100%, right? So we know. Okay, so let's think about a terminal case actually. So there's an interesting problem here. Like the first problem is like, what if this list is, so you thinking about terminal case is perfect. I never do it this way, but I think this is the correct way to do it. But like, let's think about the funny cases here. What about where the list is empty? What is the answer to that actually? So what is the answer to someone providing you an empty list? Because that's possible, right? Someone could say, hey, give me the sum of how do I create an empty list of I think it's just called null. The empty list is called null, right? So what is the answer to that? Like I mean, let's think of it. What is the answer to that?
0.
Is it 0?
I would think so.
I think for now it makes sense to me.
Error.
Or it could be an error, right? Yeah. So then it's like, are we when we look at this function, remembering that there's no like runtime exceptions we can throw and stuff. Are we saying, because when we say this, we're saying, hey, given a list of ints, any list of ints, we will give you an int. There is no other, like, should we be saying actually this is like a nullable? We could return you like possibly not an answer here. You know what I mean? I'm writing that in like C# or something. In Haskell it would be like a maybe int. It could be like, oh, sometimes you may not get an answer to this because for a weird scenario, like you gave us an empty list. But I would say for now, let's just be cool and practical and say, actually, I think Bhavesh, no, actually, like your answer, Vincent, was that the sum of an empty list actually equals 0, right? I think that's okay. So let's just put that. So the best way to do this is we just put that down. So we say, well, what does an empty list look like? An empty list looks like that, right? Sum of null. So we know that empty list. Do we know this actually about empty lists? I don't know. Let's go look at what is null. So because we don't really know the structure of a list yet. That's right, eh? We haven't really looked at what the structure of a list is. Yeah, because I was hoping to get into this today. It's called an algebraic data type. But a list, let's just read it. And I mean, don't understand, you don't need to understand the syntax. Just understand conceptually what it is. So a list, then, and this is now looking in their official definition of a list of A, so a list of any type. So A could be an int or string or whatever. A list of any type is either, so like this is an OR, so it's saying, it's really like an OR structure. So it's saying either it's null, which means that it's empty. So null is empty, or it's the cons of one of the elements of type A with a list of type A. So that means, so the definition of, this is the full definition of what is a list in PureScript or Haskell. This is it. There's nothing else. There's no other definition of list. This is it. So either it's empty, or it's an element like joined onto another list of those same elements. Does that make sense? So remember earlier when we printed a list, I think in our REPL, I probably can't launch this now because we've got errors. But earlier when where are my errors? Let me get rid of them. That one. Yeah. So earlier when we said import data.list, let's just import all of it. Can I? How does it work? Maybe just like that. Yeah. So earlier I said we created a list and we said, how do we generate a list? List.of or something. Data.list, we got it here. To unfoldable from range. Oh yeah. We used the range function earlier. So we said, cool, let's use range, and we say list from 0 to 5. And like, what does it look like? It looks like that. So, and it does look like a weird syntax, but now that we start to understand the definition of what is a list. Okay, so one quickie is like cons. The cons is just a thing. Cons is also representable as a colon, right? So when we see that colon there, we can know that there's a cons happening. And remembering that it's like infix, so that means stuff on the left would be the A, stuff on the right would be the other list. So that might be helpful. Let me make this bigger. So this list of 0 to 5 actually looks like this in memory. It's like a 0 consed onto a list of ints again. And that list is an element 1 consed onto the remaining of that list. And it keeps going until it's consed onto null. And that tells you that's the end. Because remember, null is not joined onto anything. Null is like the terminal kind of case. Okay, so without diving into that too much, actually what we're going to do, I don't know if we'll do it today, is we're going to rewrite our own list. And while we build it up, understand it a little bit better. It's very important to understand that list structure at some point, but maybe not too much right now. Now we just need to know how to kind of match them, right? So now we know if we wanted to match the empty list, it's really just null. So it's just like if you get null, so if we said, I wonder if we can do this. Can range give us an empty list? Because I think range 0 to 0 would give us the element of 0 onto the empty list. Is there something called empty? Test whether it's empty? No, not really, because it's like it is null. So null can't be shown. I don't know. So an empty list is really just that element, right? With no elements on the front. So, okay, let's pretend we all understand that. We will understand in more detail later, I promise. Okay, so there's our one terminal case, which is like, if this element, if it's an empty list given to us, that's 0. And I think that's debatable whether that's a good answer. But for our scenario, let's say it is, right? What is there any other, what about the sum of like the list, which only has one element? Isn't that a terminal case as well?
It should
Yeah,
be
I would
covered by
say so.
a general case.
Yeah, so it's like if we get a list with one element, so it's like, I'll just write it, E, and how do we represent it? It's like, that's how it looks, right? Which is how we saw in range. So if we said, hey, give us a list of one element, it looked like that, naught consed onto null, then the answer to that, what is the answer to that?
The element itself, I think.
Yes, genius. So in fact, there's two terminal cases, well, kind of, right? There's two like cases that are obvious, non-recursive answers, right? So depending on the context, if the guy gives us an empty list, it's like immediately a terminal case of 0. If he gives us a list with one element in it, we know the sum of it. It is the value of that element, right? Okay, so now I think we've got enough terminal cases. Let's get rid of that. So now what happens if they give us something else? So I suppose we could say, well, like now you could give us a list with 2 elements, right? It could be element 1 onto element 2 onto null. And that would be like the answer would be element 1 plus element 2, right? Make sense? And then we could keep going. Element 3 onto the front plus element 3. And then you just keep going. So you just keep writing this. And eventually you'll have enough implementations that you can deal with like fairly big lists. Okay, but we can start to see the pattern happening, right? As we add more elements, it's like, oh look, we're just adding bits onto the front, right? So any ideas yet as to potentially how we can do this more generally, so we don't have to write an infinite number of lines of code? Yeah.
I don't know exactly how to implement it, but like once you've got the so essentially what I need to know is how do you get the rest of the list? So you can just call the say first method or the first 2 methods. So you can like say some prime is equal to something that I don't know how to write plus some prime.
Yes. Okay, got you. Yeah. 100%. So I think you've got it. So I can help you with the syntax. So what you're trying to say, what you said initially is like, I need to get a handle to the rest of the list, right? To like everything other than this element that I've got, right? And so what you can do, and it's like very unsurprising, is like E onto ES would give us, so this is the element at the top, and this is everything else below it. ES is inside that, and it's certainly not null because that would match that one. So ES is the rest of the list. So does that make sense? So the way this is represented to you, it's like it's removed a whole lot of brackets because cons is like right associative. So the better way of reading this actually is like this: cons onto that, and this onto that, and this onto that, and this onto that, and that onto that. So when I match now E cons ES, E is the one and ES is that. The remainder of the list is everything on the right. Does that make sense?
Yep.
So does that help you, Vincent?
Yeah, that's perfect. So then I'd say E plus some prime ES.
Got it. That is totally it. It doesn't like this. Sum of E onto null. Is it just an? It should be called null, I think. Is it maybe because
it's not a? Maybe that's a problem.
I don't think we're importing it. Yeah, we need to import it up here. So null actually is a. I know we haven't dealt with it yet, but we imported list, so we understood the type of list. What we didn't understand, what we hadn't imported, was the type constructor called null and the type constructor called cons. So we need to extract. So we also need cons imported from list, and now that should be happy. Yeah. So the imports are weird. The imports like are also quite. So as you import a type, you don't get all the value, all the constructors of that type. You must import those also. So this is importing other constructors of type list. Okay, but there, we've got our sum implementation. Any questions there? Is it weird? Complicated?
Okay, I've got a question.
Yeah.
Why is the what's the idea about having like such a minimal sort of language where you have to import everything?
I think just for being efficient, right?
Space efficiency, maybe. Yeah.
Less importing means less garbage in your output binary and all that kind of stuff. Yeah, it's weird. I mean, I'm just doing it like that. You could just import everything from list if you wanted to. I think if you went like this, import data.list, you get everything. That would still be fine. Just your output. So like now when the compiler runs though, I don't know if it like prunes stuff. I am not sure. I just know the convention generally in Haskell certainly is like you import Prelude, like everything from Prelude, because Prelude's got your basic stuff, right? It's got like, you know, a bunch of interesting operators and equals and not equals. Like it's like the stuff that you're gonna want, right? Most stuff. There is something higher level than this. I know in PureScript it's called prim. So there is a thing called prim, which is always imported. You can't not import prim, and what the stuff inside prim, I actually can't even dive into it, but you can find it in Pursuit. This Pursuit is awesome, by the way. I'm really digging it. But there is a module called prim. It says it's embedded in the compiler in order to provide compiler support. And it's like, well, if you go and look at it, it's like, it's the definition of what is a function. You know what I mean? It's like so freaking basic. It's like without prim, you can't define a function. And it's like, isn't that interesting? Isn't it interesting that function is defined? It's like it's not built in. It's built in the sense that prim is always available to the compiler, but it's kind of externalized. There's actually source code for prim. I mean, you can go and read it. So it's like, yeah, a function is defined as anything which takes a type and a type and gives you another type. And it's like, yeah, that is what a function is, right? We know that, right? So it is itself a type. So if you think about it, the first type and the second type, that's the input to the function. This is the output for the function. And the function itself is a type. So that's what the output of the function is. Does that make sense? So like our definition, I mean, this is like total rabbit hole theoretical shit, but it's cool, is like if we look at our function sum, which took a list of ints and returned an int, and remembering that all functions actually take one parameter, like one argument, and return one result, because when you see multiple arrows going on here, you must bracket them. In your mind, they're right associative, so you must bracket them. So in theory, yes, all functions actually only take one thing and return one thing. They just may be returning a thing which is also a function, and that function may also be returning a thing which is also a function, and that function eventually, do you know what I mean? So all functions actually do follow that form of one input, one output. And then the idea of function as a data constructor is it itself is a new type. So effectively sum itself becomes a new type, which is of type function. And that's what like the definition of function is. Even the type of array is the same. It's like, oh, given an array must only hold one type. So the way you construct a function is you give it two parameters, input and output, and it gives you back that type. For array, you only ever need to give it one parameter, which is like, what does it hold? It holds ints or strings, and it is itself a type. A record has got this cool hash thing, and I don't know this that well, but I think it's called something like it's a row type. So it means it can be a variable number of these types. Hash means like a number of them. So a record can hold a variable number of types, and it is itself a type. So the constructor called record will return you a type defined by a number of types, because like records can have more than one type, right? It can have an age and a name or whatever. Number is just one. There's like, it's just the value given, and it is itself a type. Isn't that cool? So like, so prim is, so we're coming back to imports. It's like prim is always imported. You can't, I suppose you could say I want to import prim, but that is on by default. So generally the convention is you import everything from Prelude, then you get quite specific about what you import from all other modules by listing them there. But you absolutely don't have to. I mean, if you're importing everything, if you're doing a lot of stuff with a list, import the whole freaking thing. No problem. You can do that. It may just be a warning. Yeah, so it's actually saying has unspecified imports, consider using the explicit form. And that's probably a warning you could get rid of. You just say, nah, screw it, like pull everything in. So it just depends on, I enjoy doing stuff this way because it forces me to go and really understand the libraries that I'm using at like the functional level. And there's not much more, it's not much more complex than this, that like modules export stuff that are generally functions or this other thing called type constructors, which I actually want to get into now, is like that type constructor thing that we talked about. Okay, so this was this little cool functional implementation of sum of list of int. What I wanted to show you is actually it's pattern matching again happening here. And it was Bhavesh's question as to like, why would we want to name this thing? And it's like, maybe we do want to name it because it's like, remember earlier we called it list of ints. So if you still want to talk about the list as a whole list without having to break it out into its little elements, you can use this at to reference the entire list. Sometimes it's useful. It might be, I don't know why, but maybe what you're trying to add up is, I don't know, something else, like the length of that list or something. You want to call length here. You would have to go 1 plus the length of that or something. Maybe you just want to say, I just want to get the length of the whole thing. And so you could name it like that. Does that kind of make sense? Yeah? No? Okay.
Yep.
We're going to move on. So we're going to see pattern matching a lot. So this is pattern matching. This is pattern matching now on a list. So I'm destructuring that list there, which is I think pretty cool. And you can ask, and as you can see, it's like, oh, this destructures and matches an empty list. So that's useful for some reason, giving us that terminal case. This one destructures for something that's probably not an empty list because this one is more specific. That would match the empty list. This one would match anything else, which is probably a list of at least one element, right? It could be more. Yeah. Okay, happy. Keeping in mind this, maybe it's worth doing this quickly because now we're in recursive sum mode here. There would be two different ways of writing this recursively. Do you know the difference between there's two strategies to writing recursive functions? Anyone know those two strategies? The one is called, like, I don't know what you'd call it. The one resolves. So I suppose the one would be called like head recursive and the other one tail recursive. So tail recursive is the one that's often talked about, but I suppose the other one would be head recursive, the opposite of tail recursive. I don't know. This would be, if we look at this one is technically not tail recursive. Do you know why, Vincent? Why this is not? Do you know what tail recursive is, first of all?
Yeah, I do. Over here, it's not so clear to me why it is not.
Well, so it's quite easy to figure it out. It's like, which way does in which direction does it resolve? That's the way I normally try to think of it. So it's like, do we need the answer to sum for all the like remaining elements first before we add our element? Because if we do, that means it has to, it's like not tail recursive because it means, I think, is that right? Yeah, because it means that it has to maintain the stack. So it means that the stack has to resolve all the way back up before we get our final answer. So if you think about it, it's like, I suppose we could draw it out actually. We could write out, so say we had as our input, actually this is worth looking at because even I'm a bit rusty on this stuff. So say we had a list of 1 and 2 and 3 onto null, right? Okay, we're happy with that. The first time we invoke this function, we're going to go sum with that input. The list is going to look like 1, 2. I'm just going to write it because I couldn't be bothered. 1, 2, 3. Right. I'm going to leave out null because we know about it. We just assume it's there. So the first time we run it, it's going to do that. So what that's going to do is it's going to say, cool, take 1 and then add that on to the sum of 2 and 3, please. Right. And so then that's going to be invoked with 2 and 3, and that's going to say, cool, take 2 and add that up to the sum of the element of 3 and sum, and so it's going to be given a 3, and that's going to say 3, right? So you can see that, like, by the time we get to the end case here, all we're going to do is we're going to return 3. 3 is going to come up there. 2 is going to be added to 3, and that's going to resolve this. 2 plus 3 is 5, and that's going to resolve 1. So in fact, we move, if you think about like how the program evaluated this, it moved down through the stack, and then it had to resolve back up through the stack in order to get the answer. Does that make sense? So like the plus, like this had to happen first, which then pushed it down onto the stack, which got the 3. It got the 3, so it could resolve that, and now it can do the 2 plus 3, and then that resolves. So now it can do the 1 plus 5. Does that make sense? So it went down the stack, it found the last element, and then it resolved with a plus all the way back up. Does that make sense?
Yeah.
Yeah. So so the way to think about recursion is either you go all the way down to the bottom and then you resolve by adding the results on the way back up. That would be called head recursive. It's certainly not tail recursive. Tail recursion is where we add it up on the way down, and right by the time we get to the last case is we have the answer. So we need to have the answer at that point, because
you'd
then
have like an accumulator or something.
Yes, exactly. Yes, exactly. So accumulate, generally the pattern of passing an accumulator down means that you're building a tail recursive function. And the reason why you care about this is because the compiler can optimize for tail recursion. Because what happens here is we've got 3 function calls on the stack, 1, 2, 3, and it has to maintain those, because as it resolves, it has to pop the stack, pop the stack, pop the stack, run the add, run the add, run the add, and then give you the answer. And that's like not, I mean, we know that recursion has got limits, right? You can't call the same function a million times, because the stack explodes at some point. You can't have a million things on the stack, or whatever, like 4 million or whatever. At some point, there's a limit to the size of the stack, right? And so the compiler can't optimize this approach. It just says, I can't help you here, guy. Like you're making use of the stack. So an alternate form would be, as Vincent says, to use an accumulator. And so when the compiler detects that you're not using the stack, it can throw it away. So instead of it using the stack, it just jumps to the next function, just like a for loop would. Like a for loop keeps no stack, right, as it's iterating through something. So a functional compiler, when it detects tail that you're using a tail recursive strategy, will just unfold that into a for loop, basically. It'll just unfold it into a fast form and not use the stack. So let's rewrite it using an accumulator, which is the right strategy here. So it would be like, now your sum function needs to take 2 things, right? One of which being the element and the list of elements and some kind of accumulator. And that's going to be like, okay, cool. So what must we do is we must, instead of saying add it up and put it on the stack, it's like, oh no, just call sum immediately with ES, but add E to that accumulator. Does that make sense? And so we'd have to rewrite our earlier guys as well. So I'm just gonna, this is our first implementation. I'll just kill that one. We have to deal with the accumulator in all the cases, right? So given an element with a single element list with 1 accumulator, it's E plus the accumulator is the answer, right? Given an empty list and an accumulator, return the accumulator, right? So now you've got
Wait, Tom, I'm a little bit concerned here. What happens if the accumulator is not initialized? So like,
yeah, absolutely. So yeah, 100%. We're getting there. So in order to invoke this, so it looks like it's compiling and it's happy. Oh, it's not happy. Why is it not happy? Could I match type int with into something? Is it because?
I think the function definition, because it's saying we only take a list of int and we return an int. Yeah.
Genius. Yes, exactly right. Yeah. So, and this is often a problem with when you build tail recursive stuff, is you've now got this accumulator that's now tacked onto your function. And it's like, yeah, but I want to hide that from people. Like, people mustn't see this, right? This is what I think you're asking, Vincent, is like, okay, it's weird that I've now, if someone's going to call my function, let's actually do it. So we go result equals sum, and I'm going to give you a list. It's going to look like that. I want you to sum these things for me. And it's like, I can't just call it like that. It's like, I need to give you like the starting value, right? Or something, right? Result is an int, just to make it compile. Like, I don't want that. I don't want the caller of my sum function to give me the initial value. Like, it just feels funny, right? I just want it to look like that. So how do we solve that? It's actually quite easy, is we say, like, we create a higher level thingy that like when given, so like we go, well, sum actually is a list of int to int. So we can call this like maybe inner sum or something. I don't know. This is how I would do it. I think that there's maybe other strategies to doing this. And it's like, oh, okay, sum with a list is actually inner sum with that list starting with 0. Do you know what I mean? And so I must just call sum here. This is probably confused because this is using the earlier sum, so we've got to keep using prime. Does that make sense? So it's like I hide the fact that there's this internal summing function into another function which always just provides me the starting value, which for an int should be 0. Makes sense, right? Are you comfortable with that, Vincent?
Yeah.
I'm not saying this is the best way to do it. I'm just saying, like, you know, theoretically, that's how you can do it. Does that make sense, though?
Yeah, it does.
Yeah.
I'm gonna have to go. I've got stand up.
Okay.
Thanks.
Yeah. No worries. Cool. So, like, maybe a better way to like don't have two functions, right? So we know how to make this neater. Is like it's like, oh, it's inner sum with L0 where, and then we hide the inner sum like properly in this function. Do you know what I mean? And now it's like, now it's beautiful.
Yeah, that's cool.
It's semi-beautiful. I mean, it's properly hidden now. So like there's no inner sum available to the outside world, and nobody gets to see this nasty implementation detail, right?
Yeah. I'm going inside the base libraries. I'm going to call them libraries. This seems to be similar how they did the equals. So if you like look at equals as well, they did the whole equals, and then they've got like equals int, equals boolean, equals this.
Are you looking here at these
these
instances? Yes.
So they've because you can see there's equals and then equals boolean implement or however that's supposed to be pronounced. But then there's like a hidden implementation somewhere. I didn't go further down. Yeah, there it is. Of like, okay, but they imported it from somewhere else.
Foreign import, yeah. I don't understand this. I'm not quite sure what this is. I think this is where PureScript breaks into JavaScript. So I think where it says foreign import, this is a FFI, a foreign function interface. So this is where, because remembering that PureScript has no runtime, right? So it doesn't, it compiles to JavaScript in all cases, right? It's not like PureScript has a runtime, none at all. So at some point, you do have to make use of the underlying machinery, which is JavaScript. So at some point, like PureScript can't compare Booleans for you. It has to rely on JavaScript to do that at some point. And I think that's what foreign is doing. So you'll probably find this function, EQ Boolean impl, is PureScript is saying, yeah, pretend this is available to us completely. But the implementation of it doesn't exist in PureScript. It exists probably in JavaScript as a foreign. So the implementation of this function exists in JavaScript, because only JavaScript can actually compare Booleans. Like the machine itself is JavaScript. You know what I mean? The machine is not an Intel CPU or the machine is JavaScript. From PureScript's perspective, it can't like go and invoke the assembly to compare Booleans, because it's not compiling to assembly, it's compiling to JavaScript. So it has to invoke, and JavaScript is lacquer, it's a high level language, and so you can write a function like that. That's my assumption. So wherever you see foreign, I think expect to see the implementation of that function in JavaScript, but that it's exposed to PureScript as this name. So PureScript just will match them, and it just says, there's an implementation in JavaScript, takes two Booleans, returns a Boolean, and assume it exists. So I don't think we can go any deeper to this thing. So where it says implementation of EQ Boolean, where EQ equals EQ Boolean imp, it's like, that's it, boom, that's the end of PureScript. From here on is JavaScript for that function. Does that make sense?
That makes sense to me.
Yeah, I think it's called an FFI often, a foreign function implement, FFI Haskell. Yeah, so like foreign function interface. So of course Haskell can invoke C++ functions or other language functions, and that's how it does it, using that foreign thingy. This would be very PureScript specific, but I assume that it's inspired by Haskell's approach to it. Okay, good. I think we've tackled some good stuff here. Pattern matching and as well as recursion, tail recursion. The opposite is, I think it's called head recursion, I assume, I don't know, stack recursion or something, not tail recursion. So what I was thinking of doing is diving into something called, actually it's got many names. The name I often call it is discriminated unions, or I see often they're called tagged unions, which is also a good name, tagged unions. And in Haskell would be called ADT, algebraic data types. But I'd say tagged union is probably the best name here, unless you come from like a C++ background where discriminated unions were an important thingy. So maybe actually it's interesting to understand this. Do either of you guys use C ever? Did you ever use unions? So there was a structure in C called union, where you could say union person or something, and within a union, because remember you've got struct, right? So you have struct of person, and struct can have like age. I'm writing this badly, but like age int and name, you know, whatever, string or something. Like that's a struct, right? A union is to say actually like I want something, but it could be one of two things or one of many things. It's like one thing, but it could take on the form of different things. Union is maybe a bad word because like you feel like it brings the two things together. It actually isn't. It's a choice of one or the other. So if you had a union of, I'm trying to think of where a good example of a union might be. If like
so the only place I can think of one that I've seen recently is in GraphQL. They've got as well unions where it's along the lines of what you're describing, where it's like you'll have person who's got like foreign person and local person. Like one has a passport, one has an ID, or whatever.
Yes, exactly.
Yeah,
so that's a union, right? So
person.
Yeah, that's a brilliant example. So like a person can either be a local resident, you know, local, or a foreign resident, foreigner, right? Absolutely. So it's like a union is a structure which is, so when I think about these things, actually I think it's a good way to think about it. These are like and types. They're like, it's and. It has an age and a name, right? Whereas a union is like an or type. Do you know what I mean? Where it's like, oh, it's a local or a foreigner, right? This is the two differences. And actually it gets like sometimes in the very mathematical world, they get quite hung up on this like or and so this is often called a product type, because it's like if you think about how many combinations of struct person there may exist in the whole world, it's like it's the number of combinations of age multiplied by the number of combinations of name, right? So if you're trying to map, like trying to build out every possibility of person, it would be like if age had 10 possibilities and name had 20 possibilities, the total number would be 10 times 20. That's how many possibilities there would be, right? So it would be age times my name, making it kind of like a product, right? And or types are often called sum types in maths. And it's because if you look at this, it's like, well, how many combinations of local can you have? Say maybe there's, I mean, this is total like rubbish, but like imagine there were 3 possibilities of locals and 5 possibilities of foreigner. It would be number of possibilities of local plus number of possibilities of foreigner, right? So it's a sum type. Does that make sense? Like it is wacky in my mind that I would call something like this a product type and I'd call that a sum type, because it's not really a sum or a product going on. But like if you think about the potential possibilities, it does make sense. It's like the number of permutations of this would be this plus that. That's the total number of permutations. Whereas the total number of permutations of this would be this multiplied by that. So when you reduce it down to mathsy type stuff, it does make sense. It's a product type, and this is a sum type. You comfortable with that? Just, I mean, just in theory, right? Just the theory of that.
Yeah, sort of.
Makes sense, right? So you've got these two different types in other languages, structs and unions, right? And the one is an AND type. It joins things together, and it keeps them joined. Whereas a union is like, oh, no, it can only be one of these things. So like either it's that type or it's this type, right? It's just like conceptually. And actually, like if you think about C#, this may be more like an enum, if you think about it. So an enum is more of a sum type, because an enum can only, even though it has many possibilities and many different fields in it, it can only ever be one of those things. Do you know what I mean? So like an enum is probably closer to a sum type thing than a struct or a class or whatever. So, and quite often, like a lot of languages don't have great support for this idea, this like idea of this union. So yeah, and even in C, which supported a union, it was like, well, when I get so say at some point I got like a person, right? Fine, I've got this S structure available to me. It would be impossible to know, well, which one is set, because C would go, oh yeah, you can go .local on it, no problem, and you could go s.foreigner on it, no problem, because they're both valid, they're both fields on it. So it was kind of your problem as to like, well, which one is it? And so often the strategy in C, and it's like, okay, that's like, for me, it's a half-baked feature. The strategy in C was to say, well, the way, oh, if you want to use it like that, like it's in one or the other, then you must introduce like a new struct called person. And in that, the first field should be like, you know, is it local? And then in there have the union of person as P or whatever. You know what I mean? So, sorry, I won't put union there, repeat it. And then it was like, oh, you must use it as a struct. And then it's like, okay, so now I can go if s dot is local, cool. Now I should be able to use s dot person dot local. Nothing stops me from going s dot person dot foreigner. So it would be, yeah, but that's just a bug, right? This would be bad, good. That would be the pattern in C. So in C, it was like, oh, it's your problem. Your problem as to knowing which one of these is set, because both of them you can access. Do you know what I mean? So you needed to, and so this pattern was called, this field here was called the discriminator. Like it's a pattern. You know, introduce this discriminator so that you know about the union. Does that kind of make sense? And it's like, obviously this is crap, right? This is like, okay, so it was hard. In C, you could make a lot of mistakes, and you had to know these patterns. If you wanted to use union, it was a dangerous structure. A lot of people would say, like, don't use union; it's too dangerous. But it's a very handy structure. Just have good, just be very disciplined about its use. So anyway, if any questions on that, I don't think you need to really care too much about it. Anyway, in Haskell PureScript, they've got like a better version of this called a discriminated union or a tagged union or an ADT. And so I think we've got a thing called data. So data, remember earlier we used type. So we said, oh yeah, type person equals like age with int or something, right? We could introduce a type with a person, and this was using record syntax. So we're saying, cool, there's a new type called person, and here we're going to use a record. If you look at that, you can see quite clearly that, like, oh, look, records are kind of product types. Does that make sense? So it's like a person must have a name and an age. It's like definitely a product type, right? It's both, name and age. There's no option there. Whereas if we wanted a sum type, we could use the word data, and it would be like person. And now we can say, okay, well, what is a person? Either he's a local person or he's a foreign person. And the correct formatting would be like that. Something like that. Let's say call this person details or something. Like this, why not? conflicts with the name person because we've got person already. Person prime is our solution to all problems. And it's like, oh, okay. So now we can, so when we construct a person, we can't construct it directly. We have to use one of the particular constructors. So these are called constructors of type person. So there is a type called person. Say we say, hey, S is a person, but S is equal to a local person. Doesn't like it? Oh, local person. What have I done here? It's because I've got
the little
person prime. Sorry, yeah, exactly. Yeah. So does that make sense? So if we want to construct an S, which is of type person prime, we can't construct it as a person. We have to use one of the discriminated, one of the type constructors, one of the constructors of person. Does that make sense? So then you might say, well, what if local person has got stuff attached to him, right? He may have a name and an age or something. You can just put it in here. So you could say, oh, a local person has got a string as a name, and he's got an int as a name, whereas a foreign person has got, what should we say? He's got a string, and he's got an age, of course, but maybe he also has like how many years he's been a resident or something. So another int. So it's like, okay, cool. So when I construct a local person, I'm going to say, hey, he's a Tom, and he's of age 39, that's totally fine. If we had a T, which is also a person, T is a foreign person. He has, who's a good foreigner? I'm going to use you, Miguel. I don't know your age, 30 something, 30, I'm guessing. And how many years you've been a resident. So let's pretend you've been a resident for 10 years. There's a Miguel. So it's like, that's pretty cool, actually. So it's kind of like enum-ish. You could think of it kind of like as an enum or something, or like even like an inheritant class, like a class,
like abstract class as
Yeah.
well, because you
Yeah,
can't
yeah.
create person by itself, but
Yes.
you can create the derived classes. I'm probably
Correct,
wrong word,
yeah.
but like from that side. So it's because like if we look at it like a very like approach is like you have
Yes.
shape. You can't create a shape, but you can create
Yes.
a circle which inherits
Yes.
from shape.
For sure. Yeah, I don't think that's a bad way of thinking about it, actually. Like, so if you think about data, like, I mean, person prime, a person prime is like, it's like an abstract concept. It's like it's a thing that you kind of can't directly, it's really like, I suppose, a class of these things, which is really the combination, actually the sum of all of the particular types inside of it, if that makes sense. Yeah. So I think to think of it like a class inheritance is not a bad way to do it. I think this is probably the closest analog. It could be. There's something else called type classes, which might also be a similar analog. I don't know. But yeah, absolutely. So of course, like, we're putting typey things here, and it feels weird because we're kind of not naming them. But of course, like the type that you put here could be, like record types inside that thing. Do you know what I mean? So does that kind of make sense? So it's like, oh, okay. So a person is a local person. All local people have got like details, same as foreigners, but foreigners also have this other thing. So you can kind of go and make this like quite nicely more explicit. Like maybe this int here, you say, well, it's horrible because I'm not naming it. And I'd really love to give it a name. You can. So you can say new type, and it's like years of residence. How would we do this? Years of residence equals int, I think. I think that's okay. Is it like that? Years of residence. Oh, sorry. I think it's got to be years of residence equals, and then you kind of name it again because it's a new constructor. So you could say years or lived. Well, let's say like resided in country or something over there, and you could say, well, this is a person details with a years of residence, and when we construct, so let's go and fix our constructor here. Yeah, because these are going to be problematic for now. So when we create a local person, we've got to call it with a person details. So we go, okay, cool. A person details, like we can construct this thing, right? We go age. Sorry, I don't think the order is important. Name is Tom, and age, I'm just making a mess of it. We can clean it up later. And Miguel would be name and age and 10. And now it's saying, okay, yeah, but 10 is like an int, doesn't necessarily match a years of residence. So it's like, okay, we need to construct it. Resided in country 10. So it's like we can start to give these. So if you think about this one, new type, actually these are all the type keywords you kind of need to know. You need to know about type, which is kind of really for defining records primarily, I think. New type is saying it's kind of like a one-to-one type of mapping. It's really, new type is really very much the same as data, just it has a single constructor. Like it's just only got one option down below. But the cool thing is it kind of ends up naming it, which is pretty handy. This could match that. So we could say that. This is the constructor name, and that's the type name. They're different things, actually, but you can name them the same to make it confusing, and very often done. And it like does make sense, but you must explicitly separate them in your mind. And then data is a person. This is a sum type because it's got various choices underneath. Or it could be like a, I don't know, illegal person, you know. Person details. I don't know. You can like add many things. Any of this stuff making sense? We've kind of run over time, so I don't think we've got a lot of time to spend with it.
So far from like the analogies we've used, I'm able to follow. I think practice might determine otherwise, but so far theoretically it's making sense.
Matthew's got this because he knows Elm.
I had forgotten, but now I remember.
Yeah. So Elm does this beautifully. Like, I mean, this is a core piece to Elm for sure. Like when you build up. But maybe what is interesting for you, Matt, is is like the product versus sum type. I know we chatted about it earlier. I've been thinking about it over the week. Is like I think that kind of makes sense. It's like the or type versus an and type. So when you think about data modeling, you must think like, what are the, you know, when data comes together, like this person, it's like, oh, local people versus foreign people. That's like an or type of data problem. Whereas a person's name and his age, that's like an and type of thing. So I quite like the idea of thinking about it like that. So when you model your data, what you're trying to remove is like this impossible stuff, right? Because without this kind of thing, if we think about how would we have supported this if all we had was records, we would have had to have like is foreigner, right, as like a Boolean or something. And then you would have to have like years resident or something as an int. That's assuming that there was no concept of illegal person. And now it's like, okay, so now Tom needs this like weird stuff, like is, you know, to construct this thing, I say false. And now it's like, well, what's years resident? Like that doesn't make sense for me because I've always been here. So like, do I go -1 or something? I don't know. So like and types, although we use them almost everywhere, like that's the weapon for all things. It's like some of the relationships inside this thing are actually or type relationships. It's like years resident only makes sense if this thing is set. Do you know what I mean? So then you can start to factor that out and go, well, actually, what are we doing here? What is the relationship between like the actual domain, like foreigners and locals, and like how are they different to each other? And then model it like that. Model it with an or, with a sum type. Do you know what I mean?
Yeah, it makes sense. I have a question. What is that new type thing on years of residence?
Yeah, the new type, it's actually a good question. I don't know why you wouldn't just go data. Yeah, because it's the same. I mean, I would assume it's the same. So it's saying like, all I'm doing is I'm kind of naming an int. I'm saying, oh yeah, there's like, I'm using an int, but I'd like to give it a name. There's a lot of good reasons to like name ints, right? So it's like if I'm writing a function which takes an age of someone and gives, you know, it's the birthday function, right? Like when I look at this, I go, if f is an int to an int, it's like it's not that explicit, right? I would love this to say, hey, f is like the age of someone, and it gives me back an age of someone, right? So then I can do that by going new type age equals age, which is an int. And so it's saying, oh, age is a new type. There's a new type called age, and it's only constructed in one way by going age and providing an int. So it is an int. And there's only one way to get the age or to set the age is through an int. That part is confusing there probably, and if it looked like that, you'd be okay with it, right? You would say, yes, age is an int. So wherever I see age or int, they're interchangeable. And so the cool thing is, like, from a code writing perspective, I can take a person's age and return that age plus 1 or whatever, that's the birthday. Probably need lots of primey things here. And so when someone invokes this thing, they can go f prime prime 10, you know, and it's like, oh yeah, they're interchangeable. So you've given me an int. That's cool. I can construct an age from that. The compiler's not going to do that for you automatically. You have to provide it with a constructor, which is why we put that constructor there. And you would have to, when you call it, you have to construct that age. So when I say construct, don't get confused by object construction. It's different. I'm constructing a type. Does that kind of make sense? So it's sort of what new type does is it gives you a way of saying, oh, I want to just be more explicit about my function f. I want people to know that it takes an age. It's not an int, because then you might get confused that it could be like a sum or whatever. It's like, this is more explicit. It goes from an age to an age.
Yeah, that makes sense.
Yeah, when I read that, I get confused by that part, but it's not that confusing when you understand this part, that it's, fundamentally it's just a data of one type. So age can only be constructed in one way. Something like that. We're out of time, guys.
Awesome.
Anything else? Did you miss the core
Not
of
for
this,
me.
Bhavesh? I think Bhavesh disappeared for
I
a few
did.
minutes and missed like probably the guts of it. Maybe just rewatch that part, and I think we'll dive into this more on the next the next session, because I think we'll use them more, and I think when through their use they'll make more sense.
That'll be great.
Yeah. All right. Cool. Thanks, guys. Have a great Friday.
Cool. Thanks, Tom.
Thanks,
Speak to
Tom.
you later. Ciao.
Thanks,
Ciao.
Tom.
Ciao.
Cheers, guys.